Hi guys, so in this video we are solving for the unit tangent vector, the normal vector, the binomial vector and the curvature. Okay, so consider this problem. The position of a moving particle is given by a vector function whose equation is given by r of t is equals to 2 cosine t I hat plus 2 sine t j hat plus 3 t k hat, and we have to find the vector, the unit vector, the normal vector and the binomial vector, and the second part is to find the curvature. Okay, so to find these, here are the formulas that I wrote here. So here are the formulas that we'll be needing to calculate it. Okay, so to find the tangent vector, so what do? We take the derivative of the vector function and then we divide it by the norm of the vector. And for the normal vector, if we have the tangent vector, we take the derivative of it and then divide it by the norm of the tangent vector. And for the binomial vector, we simply cross product these two, the tangent vector and the normal vector. And for the curvature, there's two ways to find it. If we're given the tangent vector, we can simply take the derivative of it and take the magnitude of it and divide it by the magnitude of the derivative function. Okay, or we can just do, if we're not given the tangent vector, then we can do it like this. We can cross product the first derivative of the vector function times the second derivative of the vector function and divided by the norm of it and cube root it. Okay, and make it to the power of 3, not cube root. Okay, and here I'm gonna be solving it with this method, and if you want me to solve it with this method, I have made a video on that, so you can check that out. I'll provide the link in the description below. Okay, so let's start with the problem now. So first, we are finding for the tangent vector. Okay, so this is the equation. So what are we doing first? First of all, we have to calculate for the derivative of the vector function. Okay, so to do that, we're given this vector function, we are taking the derivative of it. Okay, so we're taking the derivative of the vector function, so we do 2. Okay, and just a side note, the derivative of sine of x is equals to cosine x, and the derivative of cosine x is equals to negative sine x. Okay, just remember this. Okay, now let's continue with differentiation. So we're differentiating this equation. Okay, so 2 cosine t I hat, so the derivative of cosine t, we know it's negative sine t, so negative sine t I hat plus 2 sine t, so 2, because it's a constant, stays there, and then the derivative of sine t is cosine t j hat plus derivative of 3t, it's simply 3 t hat. Okay, so we have the derivative of the vector function. Now what is the next step? Okay, so the next step, as you guys can see here, is to calculate for the norm of the derivative. Okay, so let's find that. So the norm of the vector function would be squaring each component, okay, and then square root the whole thing. Okay, so this gives us 4 sine squared of t plus 4 cosine squared of t plus 9 and square root it. Now, can we simplify it further? Just think about it. Yes, we can. So how do we do that? So for this, you just have to remember a trig identity. So let me write it over here. The trig identity is, okay, so the trig identity that I will be using is sine squared of t plus cosine squared of t is equals to 1. Okay, so this is the trig identity that I'm gonna applying it here. But to use it, you see here it's a 4 here. So to use it, I'm gonna have to factor it. Okay, so for that, let's factor out the 4. So we're left with sine squared of t plus cosine squared of t plus 9 and then square rooting the whole thing. So then this equation can be replaced in here now with 1, okay, because it's exactly the same, so we can replace it with 1. Okay, now what's 4 plus 9? That's 13. So this is 13. So sorry, the norm of the vector function here, it should be the norm. It is 13. Okay, so we have the two components, the two things that we needed to find the tangent vector, the derivative and the norm of the derivative. So we just have to divide each thing and we're gonna get our tangent vector. Okay, so the tangent vector is equals to this thing that we have in here, -2 sine t I hat plus 2 cosine t g hat plus 3k over square root of 13 that we just calculated here. Okay, you see in the formula. Okay, so you can just leave it like that, but I think it's better to write it like this, like separating each component. Okay, over square root of 13 and then cosine tg hat plus 3 over square root of 13 k hat. Okay, so this is our unit tangent vector. Okay. Okay, now let's move on. Now what is the next step? We have to calculate or find the normal vector. Okay, so here the equation of the normal vector is to find the derivative of the tangent vector. We just calculated for the tangent vector, so now let's take the derivative of it. Okay, so taking the derivative of this thing, taking the derivative of it, I'm just gonna write it here. Okay, now taking the derivative of it, this is the constant, stays in there. Okay, and the derivative of sine t, like I said before, derivative of sine x is cosine x, derivative of cosine x is negative sine x. Okay, so derivative of sine x, it's cosine t I hat plus 2 over square root of 13. Derivative of cosine t is negative sine t, so we have to put a negative in here. Okay, so negative, and then sine t g hat plus 3 over n, sorry, this is a constant, right? And what's the derivative of a constant? Derivative of a constant is 0, so we do not write it here, or you can write 0 k hat, but it doesn't mean anything, so we're just gonna leave it like that. Alright, so this is simply the derivative of the tangent vector. So what's the next step now? Okay, so the next step to finding the normal vector is to take the magnitude of the tangent vector. Okay, so let's calculate the magnitude. So like I said before, how do you find the magnitude? Squaring each component and dividing the whole thing and square rooting the whole thing, sorry. Okay, so let's do that. Cosine squared plus 2 over square root of 13 sine t squared, and then not forgetting the square root. Okay, so here we're left with 4 over 13. So if you want to know how I got 13 from square root of 13, so let me tell you, this is 2 over square root of 13, right? So this is same as 2 squared over 13 square root of 13 square, and this square root and square cancels out, leaving us with only 13, so that's why it's 4 over 13. Okay, I hope that makes sense. Alright, let's move on. Let's remove this. Okay, so here the cosine squared, it's gonna be cosine squared, and then 4 over 13 again, and then sine squared of t, because we're squaring it. Okay, and then not forgetting the square root again. Okay, so now, like I said before, we are going to use a trig identity to simplify it further. So that this trig identity that I used earlier, sine squared of t cosine squared of t is equals to 1, and to use that, first I'm gonna have to factor 4 over 13 first. So let's factor out 4 over 13. So we can use that trig identity over here. So I'm gonna replace it with the trig identity, which is gonna give us 1 here. So the magnitude of the tangent vector is this, but we can simplify it further. So this is same as square root of 4 over square root of 13. And what's square root of 4? We know it's 2. Okay, so it's 2 over 13 simply. Okay, so now we have the two things that we needed for the normal vector, right? That the derivative of the tangent vector and the magnitude of the tangent vector. If we divide these two, we're gonna get the normal vector. Okay, so let's just divide these two. So we can write the normal vector is equals to negative 2 root of 13 cosine t I hat negative 2 over 13 sine t g hat, and all this is the tangent vector divided by the tangent vector magnitude, which is 2 over 13. So we can write it like this because it will help us simplify it. Okay, so we can write it 2 over square root of 13 and 2 over square root of 13. So, and if you see here carefully, you can just cancel these two. So what are we left with? So we're left with only negative cosine t I hat, see, negative cosine t I hat, and then negative sine t g hat, and this is simply the normal vector that we were looking for. Okay, the nt. Write it clearly. Nt. All right. So what are we looking for now? So we have got the tangent vector, we have got the normal vector. Now we're gonna calculate for the binormal vector. Okay. Alright, so the equation to find the binormal vector is to cross product the tangent vector and the normal vector. We just calculate for the tangent vector, the normal vector. Now let's find the cross product of these two so we can get the binormal vector. Okay, so let's find the binormal vector here by doing the cross product of this. So remember doing the cross product, I, J, K, and we are cross product. We need to do the cross product of the tangent vector times the normal vector. So we're gonna have to put the tangent vector first. Okay, the component of the tangent vector first. Okay, let me just remove this. Oh, sorry. It's selected an eraser. Why the eraser is not selecting? Okay, now it's working. Sorry about that. Okay, so where is the tangent vector? So tangent vector is this one, right? Okay, so let me just select it. Copy it, and paste it over here. Okay, so you know that the tangent vector is this one. So now this is the tangent vector and the normal vector. So where is the normal vector? Normal vector is just there, so we know it's there. Okay, so wait, I think it's gonna be better if I put it here. Yeah, okay. Now where's my pen? Okay, so I'm gonna cross product them. So I, J, and K. So this is negative 2 over square root of 13. I'm writing the tangent vector first, right? Okay, because it's tangent vector times normal vector. And then sine t 2 over square root of 13 cosine t 3 over square root of 13, and then I'm gonna write the normal vector, which is negative cosine t I hat negative sine t g hat, and then for the key hat, you see there is no key hat component here, so that's 0. Okay, now let's calculate the cross product. And you remember doing the cross product? I hope you do because you're gonna be needing it here. So okay, so what do we do? So we need to calculate for the I hat first. So we're gonna cross the column and the row. So then what do? We multiply this like we do cross multiplication. So we're gonna multiply this times this, which gives 0, of course, and then we have to do negative this times this. Okay, so the negative and negative here, these two will cancel out each other, and then we simply need to multiply this. So this is going to give us 3 over square root of 13 and sine t, right? So let me write it here. So this is going to give us sine. Okay, yeah, I can just write it, sine of t times 3 over square root of 13 I hat. Okay, now let's move on. Okay, so now we're at g hat. So for g hat, we're gonna cross out the jth column and the jth row. And if for the g hat, remember we have to put a negative here because it's like this, it's plus minus plus. So that's why the first one was plus and the second one is negative, and then the kth will be positive as well. Okay, so now what do? We do this times this, which gives 0, of course, and then we do negative this times this. Okay, so this gives us cosine t. Okay, so of course the negative cancels out, so this is gonna give us positive cosine t times 3 over square root of 13. Okay, so let me write it over here, plus cosine t times 3 over square root of 13 g hat. Okay, now let's move on. We're on key hat now, so crossing out the column of the key hat and the row of key hat. So now we don't have any 0 here, so we have to multiply this times this. So you see the negative cancels out and we're left with these two, so we have to multiply this. So it will be 2 over square root of 13, and sine squared times sine squared, this is sine squared. Oh, sorry, I mean sine t times sine t, this is going to give us sine squared of t. Okay, and then we will multiply these two, which will give us and of course not forgetting the negative when we go from the bottom to the top. So then these negative will cancel out, and this is going to be this times this, and this is going to be cosine t times cosine t, that will be cosine squared of t and 2 over 13. Okay, so let me write it over here. So that would be, okay, right, this times this, okay, cancel out, it will be negative 2 over square root of 13 positive, and sine squared of t, and then negative this times this, and then so the negative cancels out, so that would be positive 2 over square root of 13 cosine squared of t k hat. Okay, all right, so what do we have now? So we can just simplify this to 3 over 13 sine t I hat plus 3 over 13 cosine t g hat plus 2 over 13, and yeah, this whole thing is k hat. Okay, 2 over 13 sine squared of t plus 2 over 13 cosine square root of t k hat. Okay, and here you guys notice that we can use the trig identity here again. The trig identity of sine square root of t plus cosine square root of t is equals to 1. And remember, to use this, we're gonna have to factor here the 2 over 13. So let's do that. Sine t I hat plus 3 over square root of 13 cosine t j hat. So now factoring out 2 over 13. This gives us sine square root of t plus cosine square root of t k and k hat, the whole thing. So this is going to be replaced with this, giving us 1 over here. Okay, let me use a different color so we know that we are replacing this with 1. Okay, so now the final answer is going to be here for the binormal 3 over 13 cosine t j hat. This is going to be replaced with 1, so here we're only left with 2 over square root of 13 k hat. Okay, so this is the answer for the binormal vector, but we still have one more question to do. Okay, so for the binormal vector here, okay, we just calculate for the binormal vector. Here we have to find for the curvature. So the part B is to find the curvature. And to find the curvature, if we're given the tangent vector, in this case we just calculated it. We need to find the derivative and the magnitude of it. We're given this as well because we calculated for the normal vector. So we have this, the magnitude of the tangent vector, and we need to divide it by the magnitude of the vector function, the derivative of the magnitude of the vector functions, which we calculated here as well, which was square root of 13, right? And what was this? So let's find out what was that. Yeah, so here, so it was 2 over square root of 13. Okay, so because we're using this formula because we are given these two things, because we are given the tangent vector. But if we are not given the tangent vector, we would have to use this formula. And if you want to know how do we find it using this formula, I have made a video on that. You can check that out. Okay, so let's move on. So we are calculating for the curvature, the kappa. So the equation to find it is 2 tangent vector derivative of the tangent vector and r prime of t magnitude. Okay, so this is equals to, so let's go back again. So what is it? So this is 2 over square root of 13. Okay, 2 over square root of 13. And what is this? Let's find out. What did we calculate? So we calculated for this and we got 13. I mean square root of 13. Okay, so now we can just, this, you know, this is same as writing this, because dividing a fraction is same as multiplying it by the inverse. So that's what I did. So it was 13 over 1, so I'm just gonna multiply it by 1 over square root of 13. So now if you see, this is 2 times 1, this is just 2, and this is square root of 13 times square root of 13, which is 13 square, so which is going to be square root of 13 square, and the square and square root cancels out, leaving us with 13 only. So we're gonna write 13 only. Okay, so 2 over 13. So this is the answer for the kappa, 2 over 13. Okay, so that was it for today's video. I hope you enjoyed watching it, and I hope it was helpful. If it was, please consider subscribing. Thank you. Bye.